Hi there and welcome to Penguin Learning. In this National 5 and GCSE Maths lesson, today we are going to have a look at how we simplify fractions. To begin the lesson, we're going to have a quick recap on the basics we need to simplify numerical fractions, and then the focus of this lesson is going to be how we simplify algebraic fractions, which is fractions that can contain variables such as x and y, but also numbers too. And then we're going to go over 5 examples that you can follow along with at home to give yourself some practice, and then at the end I'm going to give you an example to try by yourself. So, let's get started.
Ooh la la!
Okay, so in today's lesson we are going to focus on fractions, and in particular how we simplify fractions. In previous lessons, we've said that a fraction represents a portion or a part of a whole thing. So let's look at this here as an example. So let's pretend here that we have a pizza, and this pizza is divided into 4 slices. And of the 4 slices, we take 2 of them, so this one here and this one here. And to write our number of slices that we have as a fraction of the whole pizza, it would be 2 because we had 2 slices, and that was out of a possible 4 slices, so the fraction would be 2 over 4. But we also know that this fraction here can be simplified, and it's just common practice when we work with fractions, and just in algebra in general, we want to leave our final answer in its simplest form possible. And the way we do that with fractions, in particular numerical fractions which we have here, what we look for is a common factor between the top number, which we call the numerator, and the bottom number, which we call the denominator. So what we want to look for is a number that can be divided both into the numerator and the denominator. And we know of course that 2 goes into both 2 and 4. So we know that simplifying that is going to go to a half, but just to write out the process of this, what it's like saying is on the top we have 2 times 1, which is 2, but then also 2 times 2, which is 4. And how we get to a half is if we have the same number on the top and the bottom, and they'll be multiplied together like they are here, then the numbers can cancel out. So we said that 2 goes into 2 once and into 2 twice, and that means our fraction is then left with just a half. And this is the most basic example because if we look at this here, we can clearly see that these 2 slices represent half of the pizza. So therefore 2 over 4 can be simplified to 1 over 2 or a half. And it's important to realise that when simplifying, there can sometimes be a common factor between the top and the bottom numbers, but what we want to look for is the highest common factor, and if we can find that, then it's going to leave it in its simplest form. So let's have a look at this example now. If we want to simplify the fraction 12 divided by 16, we have to ask ourselves what number can be divided both into the numerator and the denominator. And straight away we can see that both 12 and 16 are even numbers, so that would mean 2 can be divided into both of them, because 2 times 6 is 12 and 2 times 8 is 16. But remember, we want to look for the highest common factor, and in fact if you realise it, we can see that 4 goes both into 12 and 16, so that means we can write it out as 4 times 3 because that's 12, and then the bottom is going to be 4 times 4, and then because we have 4 twice, 1 on the top, 1 on the bottom, that means we're left with a fraction of just 3 divided by 4, or in other words 12 over 16 can be simplified to 3/4. So again, look for a common factor between the top and bottom numbers, and then we can cancel that out as we can see here. But sometimes when we go to solve problems, especially in the National 5 and GCSE Maths exams, we don't always have numerical fractions. And what I mean by numerical, just simply a fraction with numbers on the top and the bottom. But we're also going to look at something called algebraic fractions, which involve fractions including both numbers and variables. And we can see in this example here we have x's and y's on the top, so we have 2 variables. And how we simplify algebraic fractions is the exact same process we would for numerical fractions, and that means we want to look for a common factor between the numerator and the denominator, and in particular a highest common factor of that. So how do we do this example? Well, just to illustrate the point, what I'm going to do is write x squared on the top out as x times x because we know x times x is x squared, and then that's times the y, because x squared y is just the same as x squared times y. And in the bottom, the exact same thing. We have x times y squared, which can be represented as y times y. And then what we look for is if we can cancel something out that we can see on the top and the bottom. Okay, so we have two x's on the top, one y on the top, two y's on the bottom, and one x on the bottom, okay? So that means we could maybe cancel this x with that x, and then what we can also do is cancel this y with that y. So we cancel out same things that's multiplied together on the top and the bottom, and then that just leaves us with a fraction equal to x divided by y. So x divided by y, or x over y, is the fraction x squared y divided by xy squared in its simplest form here. And just one thing I want to highlight before we go on to another proper example is that we could only simplify in the last example because the terms were being multiplied together. So what I mean by that, in this example here, instead of x squared y, we have x squared plus y, and instead of xy squared, we have x plus y squared. And because they're adding together and not being multiplied together, that means we can't take a common factor out of the top or the bottom, and that means we can't simplify or cancel out the same way we did the last time. So the terms have to be multiplied together, and then you have to find the same on the bottom and the top to cancel out. Now let's have a look at this example. Here we have the algebraic fraction of x plus 2 on the top, and then on the bottom we have two sets of brackets, x plus 5 and x plus 2. And because the terms are grouped together in brackets, that means we can treat these brackets as individual terms of their own. And that also means that on the bottom here, because we have two sets of brackets, we know that they'll be multiplied together. So x plus 5 all times by x plus 2. And that means because we have an x plus 2 on the top and the bottom, that means they can just simply cancel out. And that means we're left with, well, because we've cancelled the x plus 2 out on the top, that means what we'd be left with, well, to begin, we would have like 1 times by x plus 2, because 1 times x plus 2 is just x plus 2. So if we get rid of that, we would just be left with 1 on the top, and if we've cancelled the other x plus 2 out on the bottom, we would just be left with the x plus 5 on the bottom. You can either leave this in brackets or not, it's up to you, but that means this fraction simplified to 1 over x plus 5. And that just shows that if we have brackets, they can be simplified the exact same way we would with a numerical fraction or just another basic algebraic fraction as well. Now example 3, we have the algebraic fraction of 2t minus 1 to the power of 5 on the top and 2t minus 1 to the power of 3 on the bottom. Okay, now just to think back what it means if we have something to the power of 3 or to the power of 5. If we say we have x to the power of 3, it means we have x times x times x. So x multiplied by itself 3 times, and x to the power of 5 is x times x times x times x times x. And just highlighting this because that these brackets to the power of 5 and this one to the power of 3 is the exact same thing as we see here. So 2t minus 1 multiplied 3 times, and this is 2t minus 1 multiplied 5 times. And because we have 2t minus 1 5 times on the top and 2t minus 1 3 times on the bottom, that means these bottom 3 would cancel out with 3 on the top also. So the 3 in the bottom cancel out, and we're left with, that means then 2 on the top. So that would look something like this. We would have 2t minus 1, and that would be to the power of 2, because that's all that's left after the other 3 have cancelled out with the bottom 3. And then on the bottom, it would just simply be left with a 1, as the 2t minus 1 all cubed has disappeared. And if we know that we divide anything by 1, we're just left what was on the top. So that means this in its simplest form would be 2t minus 1 all squared. And again, this would just be the exact same process as simplifying a numerical fraction. What we would do is cross out what we have on the bottom with the top, and because we have 3 2t minus 1s on the bottom and 5 on the top, these 3 cancel out with 3 on the top, so that means on the bottom they disappear and we go to 1, and then we're left with the 2 remaining ones on the top, so 2t minus 1 and another 2t minus 1, which is just written as 2t minus 1 all squared. Now what about this one, question 4? What if we want to simplify the algebraic fraction x squared plus 4x, and then on the bottom we have x squared minus 16. Now again, remember what I said before, we can only directly cancel out if we have multiplication terms, but what we have is an x squared and a 4x and an x squared and a minus 16. So that means we have to treat this as two separate terms on the top and two separate terms on the bottom. Okay, so how do we simplify one like this? Well, again, what we can do is use factorization in order to group things together as the one term, and then hopefully by doing that we can see a similar or same term on the bottom with the top, and that means we can then cancel. Okay, so let's have a look to factorize the top first, the numerator. We want to factorise x squared plus 4x, and the first thing that we always do when we go to factorise is look for a common factor. So a common factor between x squared and 4x. Now we know that x squared is just the same as x times x, and then 4x also has an x as well. So that would mean that x can be a common factor, okay? And that means we put the common factor outside the brackets, and then inside the brackets what we do is we divide each of these terms by the common factor. So in other words, x squared divided by x would just be x, and then 4x divided by x would just be 4. And then we can also check this just by multiplying it back out. So we would have x times x gives us the x squared, x times 4 gives us the 4x. So that means we know that's factorised correctly, okay? And then on the bottom, again, the first thing we always look for is a common factor, but there isn't one in this case between x squared and minus 16. So the next thing we look for when factorising is a difference of two squares. And the giveaway for a difference of two squares is, first of all, we have two terms, and the second thing is that if there's any numbers involved, it should be a square number. And what I mean by that is ones like 1, 4, 9, 16. So 16 is a square number, which means that 4 times 4 is 16. And what we want to do is be able to write the bottom in the form of a squared minus b squared, and we can see that a is clearly x and b would be equal to 4, or in other words, we can write this as x squared minus 4 squared, because 4 squared is obviously 16. And then that means we can use the difference of two squares factorising of having a minus b, a plus b, and as two set of brackets. And then that means in this case it would become x minus 4, x plus 4. And we know that if we were to multiply these two brackets back out, we would get the exact same terms that we have here. So x times x is x squared, minus 4x plus 4x, so they cancel out, and then minus 4 times 4 gives us this minus 16. So that's us now factorised the top and the bottom. So after doing this, we should now look to see if we can cancel things out. And now, because things are grouped together in the brackets, we can see that this x plus 4 cancels out with this x plus 4 on the bottom. And that means what we'd be left with is x divided by x minus 4. So that would be this algebraic fraction here in the simplest form. So we're just left with x on the numerator and x minus 4 on the denominator. And again, the key thing with this question is, first of all, recognising we can't simplify in this form because these two terms are separate, because they're not being multiplied or divided together. And how we go about grouping these terms together in this case is by factorising. So we can see here that this bracket easily cancels out with this bracket on the top and bottom, and that means all we're left with this x and this x minus 4 to give us this final answer. Let's do 1/5 and final example in this lesson. So here we have the fraction 6p plus 18q divided by 3. So again, the first thing that we do is to see straight away if we can cancel anything out on the top or the numerator with the denominator here. And we can see that these two terms are separate, so we have a 6p and 18q and a 3 on the bottom. So that means there's nothing we can cancel out straight away, okay? So the next thing that we look for is to see if we can rearrange the numerator and the denominator in any way. We can't change the denominator because that's just a simple number of 3, but what we can do is rearrange the numerator or the top part in a way. And we do that again by factorising. So we look to see if there's a common factor, first of all, between 6p and 18q. And looking at the numbers straight away, we know that 6 is divisible both by 6 and 18. So that means 6 can be taken out as a common factor. And that means we're left in the brackets of 6p divided by 6, which is p, and then 18q divided by 6 would be 3q. And then on the bottom, we'd be left with just the 3 again. And then now, because it's like 6 multiplied by this bracket, that means we can treat the bracket and the number separate. So that means now we can cancel out. So we know that 3 is divisible by 6, so that means what we can say is, if we divide both of these numbers by 3, 6 divided by 3 is going to give us 2, and then 3 divided by 3 is going to give us 1. So that means the 2 on the top now and the 1 on the bottom changes the fraction to 2 in the brackets, p plus 3q divided by 1, and then as always, if we divide by 1, then we're just going to be left with the same what was on the top. So 2 in the brackets, p plus 3q. So again, we factorise to allow us to cancel out. In this case, it was the two numbers, 6 and 3. We divided both of them by 3. 6 divided by 3 gave us 2. 3 divided by 3 gave us 1. So we do the same on the top as we do to the bottom, and that gave us the final form that we had here. So here's an example you can give a go yourself. So I want you to try and simplify the fraction x squared plus x minus 2 divided by 2x squared plus 2x. Try this yourself and I'll give the answer down in the comments below, and I hope by doing the examples you had in this lesson will allow you to go on and get the correct answer for this one. So I hope this lesson has been helpful to you on learning to simplify algebraic fractions. And if that's been the case, like the video, share it with your friends, and make sure and subscribe to the channel for future videos like this. And if you have any questions on today's lesson, drop a comment down below and I'll get back to you as soon as possible. As always, thanks for watching and I'll see you in the next video.